Hi, my name is Nicolas, and I did my project on the phytoremediation of contaminated soil using hemp. Phytoremediation is a type of soil remediation involving the treatment of polluted soils using plants that can and will grow in the contaminated soils. Plants that can efficiently act as a phytoremediator are a viable mitigation strategy to decontaminate areas such as farmlands and old mining operations. This process is highlighted in Figure 1. So you can see in Figure 1 that the pollutants that are stored inside the soil are accumulated through the root system of the plant and then brought up into the stem and the leaves and then ultimately the flowers of the plant. Hemp is an ideal candidate for phytoremediation due to its high metal tolerance, its ability to act as a hyperaccumulator of the heavy metals found in the soil, and also its ability to grow in various climates around the world. Also, with the 2018 legalization of industrial hemp in the United States, it has become a more viable and popular option to use as a phytoremediator. The objective of this experiment was to see if the hemp plant would grow in the contaminated soils, verify that the hemp acted as a phytoremediator, and also to quantify how much of the heavy metals that the plant would remove from the soil. The initial soil samples were collected from a junkyard just outside of Harbor Springs, Michigan. The sample was microwave digested using the Mars 6, using their cannabis plant sample, and then analyzed using the Agilent 7800 ICP-MS. And these can be seen in Figures 2 and 3 in the method section. The hemp itself was grown from seeds that were acquired from a company called Ag Marvels in Mount Pleasant, Michigan. They were grown in a grow tent in the greenhouse here on Crawford Hall on Lake State. They were grown in under a 200 by 10 watt light fixture that was presenting 18 hours of light throughout the day with 6 hours of darkness, ideal for the vegetative state of growth for the plant. Water was added every 23 hours via an automated watering system. And this can be seen in Figure 4. The plants were then harvested 2 months later, and they were separated into the root/shoots part of the plant and dried in an oven at 45 degrees Celsius for 30 minutes. They were then microwave digested and analyzed via ICP-MS system as before. In the results section here, you can see in Table 1 the average heavy metals concentrations found in the root and shoot part of the plants. From here, you can see there's on average a higher amount in the roots compared to the shoot part. And the results from the ICP-MS analysis can be seen in Figures 5 and 6. Figure 5 highlights the 6 heavy metals that are regulated by the Marijuana Regulatory Agency here in Michigan in all cannabis products. There you can see elevated amounts of copper as well as lead. And then in Figure 6, you can see 5 other heavy metals that were also found in abundance in the plant samples after their growth. Like I said before, multiple heavy metal concentrations in the plants were over the MRA action limit for cannabis products, including copper, lead, and zinc. The root samples, like I said, on average had a higher concentration compared to the shoot samples. Unregulated temperature levels and lack of outside nutrients added to the soil possibly contributed to the lack of growth of the hemp plants. The hemp plants did not make it into the flowering stage, so that's why only the root and shoot parts of the plant were able to be tested. If done on a large scale, using hemp as a phytoremediator could, over a set amount of time, help remove excess heavy metals from previously contaminated grounds, such as stated before as farmlands and old mining operations. This would allow for land once thought as unusable to be used again for reasons such as agriculture and other possibilities. I would like to give a special thanks to Professor Southwell and Dr. Wright for their guidance during this project. Thank you.